So now I want to consider the graphs of quartic functions and how we might use the axes-intercepts here to sketch the graphs of these quartic functions. But before we begin, there's going to be two extra things that we might need to keep an eye out for in comparison to cubic functions when we're dealing with quartics. The very first thing is, if we're looking at a function where we've got y equals x to the fourth, ax to the fourth, sorry, we need to keep an eye on what happens with this a value, because this a value will determine the overall shape of the graph. So for example, if a is greater than 0, what it's going to tell us is it's going to open upwards. And what I mean by that is our polynomial, after it wriggles a couple of times, is going to overall have this open upward shape to it. Equally, if our a is negative, so it's less than 0, it's going to open downwards, like this. So it's going to have this overall concave type shape to it. So that's the first thing that we have to keep in mind when we're graphing these things. The next thing that we have to keep in mind, because they are in factorised form, is we could end up with this quadruple linear factor. So a linear factor that has this type of thing here, this quadruple linear factor. Now, what's neat about these quadruple linear factors is they act very similar to what a quadratic would look like, in that what ends up happening with them as they hit the x-axis is they'll come down and they'll meet it similar to a quadratic, but they'll end up really flat. So they've got these really flat bottoms. Obviously it can be the other way around as well, depending on the value of a, of course, but it's got this real flat bottom. It looks a little bit like a quadratic, but rather that quadratic going like that, it's got this real flat bottom to it where that will meet the x-axis. So they're the two things that we need to consider and keep in mind when we're starting to look at graphing these quadratic functions. So with that in mind, let's now take a look at how we might use the axes-intercepts to graph this quadratic function just in here. Now, what I can see with this quadratic function is we've got two linear factors. Linear factors meaning that's where it's going to cut the x-axis. And it's got this repeated linear factor here, which indicates to me that it's going to go up and touch, or down and touch the x-axis at this point in here. The value of a, so the number in front here, is also positive because it's positive 1. So that means overall it's going to have this convex type shape. It's going to open upwards. So as we go through this, we know that it's going to cut through, so the x-intercepts are going to be at positive 2 on 3, so 2 on 3, and negative 3. We also know that it's going to touch at the value of negative 1. Okay, so that's what we know about how it's going to interact with the x-axis. Now we need to find where it's going to touch, or cut through the y-axis. Now to find the y-intercept, we need to look at when x is equal to 0. So we substitute 0 into the function here. So our y at that point is going to be 3 times 0, which is 0, so take 2, so that'll be negative 2. 0 plus 3 is 3. 0 plus 1 is 1, and that'll be squared. So now negative 2 times 3 is going to be negative 6. 1 squared is 1. So negative 6 times 1 is just negative 6. So therefore our y-intercept here is going to be negative 6. So from here I can now sketch a graph that includes these main points. So let me go ahead and do that. Okay, so now I've got these points. What I want to consider is just my a value again. Keep in mind it's positive, so that means it's going to overall open up. So it's going to start up here somewhere. At negative 3 it's cutting through, so it's cutting through here. It's touching at negative 1. Because it's touching, I like to just sort of draw that in so I'm aware of it. And it's cutting back through here. So it's going to cut through here somewhere, it's going to cut through here somewhere. It's also going to cut through here. It's going to turn around at some point and go back to the x-intercept and touch it. It's going to turn around at some point in here, and then it's going to continue infinitely up there and continue infinitely up there. So what you can see here, because my a value is positive, it's going to have this overall convex shape or open upwards. It's touching at -1, but it's cutting through at 2/3 and -3. And it's also cutting the y-axis at -6. So that's how we go about sketching that one. Let's take a look at one more example, but in this example I've now got a cubed linear factor. So remembering that a cubed linear factor from our previous video is where it's going to have a stationary point of inflection. So let's go through this now. The very first thing is let's describe how it's interacting with the x-axis. So we know that it's going to cut at -1. So cuts x-axis at -1. We also know it's going to have a stationary point of inflection at +4. What else we do know about it is because our a value here is now negative, it's going to be opening up downwards or have that concavity type shape, that overall concave type shape to it. But I also need to find my y-intercept, so let's let x equal 0. So substituting 0 in up here, that'll be y equals -1/4. 0 plus 1 is 1. 0 take 4 is -4. That'll be cubed. So now let's work this out. So -4 cubed, that'll be -16 times 4 is 64. So -64 multiplied by negative will be positive overall. Multiplied by 1/4, so 1/4 of 64 is back at 16. So therefore the y-int is 16. So now I've got those pieces of information, the y-intercept, my stationary point of inflection, and the x-intercept where it cuts through. Let's now have a go at sketching the graph. Alright, so now when we're sketching this, I know that it's going to be overall concave. So it's going to start down here and finish down here somewhere. At this point, it's got a stationary point of inflection, so it's going to be flat, and then it's going to curl down and curl up like this at that point. I also know it's going to cut through here. It's going to be cutting through at this point. I haven't drawn this all that well. Like that. It's going to be turning around over here somewhere, and then it's going to head down towards this stationary point of inflection. Like that. It needs to be a bit more stationary. So just a bit flatter there. So we've got to indicate that that's a real flat section just in there, a stationary point of inflection. So to summarize, basically what we're doing with these types of graphs, like we were with our cubic polynomials and our quadratic, is we've got to identify how these are interacting with the x-axis. And that's sort of determined by what sort of factor that you're dealing with. We've also got to consider the value of a and how that will affect the overall shape of the graph. And we also need to consider finding where it's going to intercept with the y-axis by substituting x equals 0 into this function up here. Once you've done that, you include all the relevant and important points of the graph, and you sketch the overall shape of the graph from that.